Hello students, welcome to this class on inheritance. It is a very important features provided by object-oriented programming languages like C++, Java, Python and others. Okay, in this class we'll discuss reusability feature provided by object-oriented programming languages, inheritance, what is it and why we need it, access specifiers, the different types of inheritance, the diamond problem, the concept about base and derived class relationship, and how constructors and destructors are dealt when using inheritance. And we'll also discuss some practical examples on inheritance. So let's begin. Genetic inheritance. What we mean by inheritance? Inheritance means using properties or behaviors from parents to children. The flow of behaviors, properties from parents to children. As you can see, inheritance is very much in nature. For example, here in the children, you'll need the features inherited from the parents. Okay, and also here in the watermelons, as you can see, there are different types. Okay, and these types are inherited from their parents. Okay, and inheritance in object-oriented programming languages, usually we define generic properties in parent classes, that is in superclasses, and these properties are more refined as specifics by the child classes. Okay, so in inheritance, new classes that have more or less refined features from already built classes that we call as parent class. Okay, and the derived classes or the subclasses, also called children classes, absorb the attributes and behaviors of the super or parent class. Okay, child classes also can add their own features. Okay, and these features are not directly related to the parent class, mean parent class cannot access to features of the child class. Okay, the new classes are called the derived class. These derived classes inherits data members and member functions from superclasses or base classes. Okay, so there is a terminological identification or identical synonyms. For example, so in inheritance, the parent class, also called is as superclass and also called as base class, is features that are inherited by child class, also called subclass, and derived class. Okay, for example, I have a parent class. Okay, for example, this is parent class A, and it has some features, and those features are, for example, some data members. Okay, for example, I have some data members, and also I have, for example, some member functions. Okay, I have data members and member functions, and these data members are inherited, or these data members are these features are used by another class that we call as child class. Okay, for example, this is the child class, and this class name is just say class B. Okay, class B. And this class, when used as inheritance, can use these data members, or they can also use these member functions. Okay, plus it can have its own features like data and functions. So this class B can inherit the behaviors, that mean the data members or member functions of the base class, and also it can have its own data members and member functions. Okay, so this is class A that defines the generics. Okay, it defines the generics. In here I have what? Here are the specifics. And the specifics, okay? And the specifics, okay? For example, this derived class can use the generic features as well as it can add on its own specific features, okay? Okay, let's consider an example about inheritance. For example, we have a generic class named vehicle, okay, that has some specific attributes and functions assigned to it. Okay, now there are derived classes from this general class, and these classes have been named as bike, truck, and car. Okay, so general vehicle has some generalized attributes. For example, the brand name or the manufacturer name, the mileage, etc. While the specifics, I mean, bike has its own attributes. For example, type of bike, whether this is a sports bike, etc. Same as a truck has its own attributes. For example, the number of wheels, the loading capacity, and so on. Similarly, car has its own attributes different from the truck and bike. Okay, so all the specific attributes, we attach these attributes to the derived classes, and meanwhile the generic attributes are accessible to all the derived classes. Okay, we'll discuss this in an example program later. Let's discuss inheritance and its types. Inheritance can be single inheritance and multiple inheritance. It means when a class is inherited from just one base class, means one parent and has a child. In case of multiple inheritance, a subclass or a derived class is inherited from more than one base classes. That means more than one generic types from multiple parent classes have been inherited in a single derived class. Okay, we have three types of inheritance. They defines the scope of the features inherited, means when they are accessible and where they are accessible. For example, public, private, and protected. Okay, for public inheritance, The derived objects are accessible by the base class objects. Okay. In private inheritance, derived objects are inaccessible by the base class. In protected, the derived classes and friends can access protected members of the base class. We will discuss these three inheritance types by examples later in this lecture. Okay, let's discuss some more examples on inheritance. For example, I have base class is vehicle. There is some spelling mistake. I'll correct it in the revised slides. Base class is vehicle and it has some derived classes, for example, truck, bike, and car. There is, for example, student is a base class, and then I have subtypes as undergraduate students and postgraduate student. Both these classes of different student types have some specific attributes. Okay, for example, in this, the number of credit hours and the semester in postgraduate student, for example, the research activity has been assigned and so on. For example, shape is a base class and there are some derived classes like circle, triangle, and rectangle. Each derived class has its own attributes. For example, circle, we deal with radius, okay, diameter, etc. The triangle, we need with sides, okay, length of the sides, the three sides, and the angle between them. And the rectangle, we are concerned with the length of the opposite sides. For example, employee is a base class, and then there are subtypes as admin, administrator, and faculty. Each derived class has its own attributes. For example, the number of courses assigned, and for example, his administrative level, okay, at which level he or she has been assigned, and the authority type. For example, examination, whether this is a midterm examination or final term examination. In midterm examination, total marks assigned to it. Final term examination has its own attributes, for example, number of assignments, number of quizzes, and the overall marking of the student and the resulting grade of the student. Okay. Inheritance hierarchy. For example, in the generic case, we consider an individual as a community member. Okay, that community member can be either as an employee or as a student or as alumni of the university. An employee, we may have this as a faculty member or a staff member. Okay, a faculty may be also assigned some administrative task. Okay, or he may be just a teacher. Okay, so in this case, the staff is single inheritance, inherited from the base class employee. Okay, an administrator teacher, for example, a coordinator of the department that is also a faculty, has two roles. At the same time, he is attached with some administrative responsibilities and he also teaches some courses. Okay, so this is a type of multiple inheritance in which case the derived class, okay, is more than one superclasses, okay, are parents. For example, here I have shape, okay, and I have categorized the shape in two subcategories. For example, on the basis of their dimensions, two-dimension and three-dimensional shape. Two-dimensional shapes, for example, circle, square, triangle. Three-dimensional space, for example, sphere, cube, and tetrahedron. Okay. Okay, what is the syntax of inheritance and how do we use inheritance in C++? For example, I have this class A, okay, which have data members defined in the private scope and member functions defined in public scope. Okay, now I want to derive a class B from this class A. So the syntax is I'll need to use this keyword class, name of the derived class, colon, the access specifier. This can be either private, public, or protected, and the name of the parent class. Okay, here I'll provide the specifics, its own attributes of the derived class. Okay, this class can also use these attributes. Okay, and they are just a shadow. Let's discuss this example, in which case I have, for example, I have vehicle as a base class, and I have two objects, truck and a car. So class vehicle has data members as brand, mileage, and available fuel. Okay, the amount of gasoline in it. It has three functions. One is create, other is drive, another is honk. In the create, I'm initializing or assigning values to these data members. For example, the brand name, the mileage, and the available fuel. The drive function is used to check the driving capability of the vehicle, or to drive the vehicle for a specified kilometers assigned in this parameter distance. Okay, in order to, what is this function doing? For example, I'm calling this function on some object. For example, drive a car, for example, 50 kilometer. Now this function will check the available fuel. For example, the distance that we want to travel, if that distance divided by the mileage is less than or equal to the available fuel. Okay, it means I have enough fuel to drive with. Okay, so this message we will display, or else it will give me this message. For example, the available fuel is too low, limited fuel, and the driving is not possible. Okay, this is the third function, while honk. Okay, and each derived object will have its own honking capability. I mean the horn type. These are the two derived classes. One is, for example, class truck, that has been publicly derived from vehicle class. Vehicle is a parent, truck is a child class. The truck has its own attributes. Okay, for example, number of wheels, and it has redefined the honk is, for example, paw paw paw. That is my own onomatopoeia for the traditional truck. Okay, the truck that sounds here. It has also car is a derived class that has been publicly derived from vehicle. It has its own data members. For example, I'm interested in the color of the car, its own honking capability, for example, beep beep. Okay, I've tested this class. I've created two objects of each child class, one object of each child class. For example, truck, car, and car. Truck.create. Okay, if you see, I don't have any create function over here. Okay, but still I can use this create using object. Why? Because this truck, this has been inherited as a child class. Okay, so I can use this generic function create. Okay, and with these parameters, now honk, I have two honks. Word is a parent and another is the child. Since child has redefined this function, so this function of the child will be called, okay, not the parent. And truck drive. Okay, I don't have any drive function, in this. Okay, so drive of the parent class will be called. Same as for the car object, using the create, the honk, and the drive. Okay, this is the output, creating vehicle types. For example, creating vehicle types, then this function is called, the drive function is called, then the create function for the car is called, the honk function is called, and the drive function is called. Okay, uh, let us see this example inside Eclipse. This is the example. I have this vehicle as my parent class. This is super class, also called parent class. Okay, I have these data members, for example, brand, mileage, available fuel. Create function takes three parameters, one for the brand name, other for the mileage, and other for fuel. Okay, if you see here in the create, I'm sending three different parameters. This is string, is the manufacturer, name of the manufacturer, and this is the mileage, and this is the fuel. Okay, in liters, for example. This is drive. If this distance, drive takes just one parameter, that is distance. Let's how the mileage is calculated. For example, I have a vehicle type, for example, Jeep. Okay, distance 100, fuel 400 kilometers. It has consumed 8 liters. Okay, so mileage is nothing but the distance consumed, the distance traveled and the fuel consumed, that is for example 8. Okay, so this is for example 12.5. It means in 1 liter it travels around 12.5 kilometers. Okay, same as for car. Okay, a little higher mileage, in truck lowest mileage. Okay, and this is my journey planner. For example, I have this mileage already known as 12.5, and I have fuel in hand is my present capacity of the fuel. Okay, for example, I have 10 liters with me. This is the known mileage, and I want to travel 80 kilometers. Okay, so I can travel, this is possible. For example, in this case, I want to travel a 200 kilometer distance, and I have 13 liters with me, and my mileage is 12.5, so this is not possible. Okay, so in our driving function, it will either give me as drive not possible, or I have driven for this much distance with remaining fuel capacity, right? Okay, so this is the distance divided by mileage. If it is less than or equal to available fuel, this will be displayed on the screen, drive for this much kilometers, and the available fuel is right now this, or else it will just show this message, limited fuel, drive is not possible, and you need a refill. Okay, then I have these derived classes, truck. Okay, that has one data members, number of fields. I haven't used it. Okay, you can do a homework reusing. For example, you can use its own setters and getter functions. Same as for this car, there is a single attribute color and this function honk. Okay, so this is creating vehicle types. Message will be displayed. I have a truck object, a car object, truck.create, 6.700. This is for mileage, this is for fuel, and I want to drive for 50 kilometers. Okay, it's Toyota car. Let's run this. Okay, so this message is displayed creating vehicle types. This is truck.honk. This SHD display. Then I have 50. So derived for 50 kilometers, available fuel is 92.53. Then this is for car, and it drive for 200 kilometers, remaining fuel is 2. Okay, let's drive the car again. Drive car for another 100 kilometers, and we want to check. Okay, it drive for 100 more kilometers, and the available fuel is now 3.4. Let's drive it a bit more, 120. Run it. Okay, with this available fuel, the driving is not possible. Limited fuel, drive not possible, and we need a refill. Okay, so if you want to refill it, for that you need to create another function that is used for refueling. For example, let me just add it here so that I can use it both in truck and for the car. For example, double available fuel. I have double. Okay, refuel available fuel plus is equal to ref, right? Car dot refuel, and I want to refuel it for 50 more. And let's drive it again and check. Okay, it was giving me limited fuel drive not possible for this 120, so I have refueled it. Okay, and now as you can see it drive for 120 kilometer, and the available fuel is 46.79. Okay, so this is how you can add functions to the parents that are directly used by the children. All right, okay, let's discuss more. Scope of accessibility. What are accessible and what are not accessible? Okay, so before discussing these a little bit hard topics, let me just give you a very simple example. Let's switch to Eclipse window. Okay, I have this simple class. Okay, where I have, for example, class simple. Okay, and I have two attributes, private, a single attribute, for example a, and two functions, void set a, integer some value, and to set this value a is equal to some value, and for example get a, and to return this cout. Let me show over here. Value of a is okay, and also return this a. Now I want to just derive class B from it. Public simple, class C from it is private simple. Okay, now add some specific features to both the children classes B and C. Okay, I have this class sample in which I have only data member declared in private scope as integer A. In public portion, I have this data member integer B. I have these four member functions: set A that sets the value of the private variable A, and get a set B that sets the value of this public, and show B. Then I have C declared in protected scope with two functions, set C and a function show C that prints the value of C. I have this class B which is publicly derived from the class sample. I have function square which squares the value of B, and another function that sets the protected value of C, okay, and show protected that prints or shows the value of the C variable. Okay, to check the working of this program, let me first come to the main. Inside main, I have created an object of the derived class, that is class B. Okay, this one, and after it I have called the function setB, where I am setting value for the publicly declared variable B to 10. Okay, so the setB function have been declared in the public portion. Okay, so I can easily use it by using object reference of the child class, that is B. Okay, then I'm calling the show B function, and if we see, the show B function is also declared in the public portion of the parent class, so I can use it by object reference. In obj.square function, if you see, the square is declared in the public portion of the child, so I can use it here. And after that, this is a single cout, and this is the show protected function. Okay, the show protected function is declared in the public portion of the derived class, which internally calls show C, and this show C has been declared in the protected portion of the parent class. So let's run it. Okay, value of B is 10. Value of B is 10. This will be displayed. Okay, after value of B is 10 has been displayed, next I am calling the square function. Okay, and the square function is square of B is B multiplied by B, that is 100. Okay, and then I'm calling this function, okay, accessible, as this B is declared in the public portion of the derived class. Of the parent class, so I can also use it by object reference of the derived class object.p. Okay, this is also accessible, and object.show protected, as I have not object.show protected, this function will be called, this internally calls show C. Okay, value of C is, as I haven't set the value of C, so a garbage value is printed. Okay, if you want to call object set protected, okay, so a value from the user will be asked. Enter value for protected value. For example, I'm entering 8 and value of C is 8. Okay, and then value of C is 8 is shown by this one. Okay, just if you want to access the protected member of the parent class, if you are unsure, this will give you an error. Why? Because this shows he has been declared as protected in the parent class, okay, and you cannot access the protected member outside the class even by object reference of the child class. Okay, so if you want to access it, you can access it through a publicly declared function in the child class, and then you can, okay, and we will study this also in this slide. For example, here I have data members declared with different scopes. For example, this is private scope, this one is in protected, this one is in public scope. Same as I have some functions, and these functions are declared as private, declared as protected, and declared as public. Okay, so both the private and the protected data members are member functions. Data members and member functions, private and protected, if they are data members or if they are member functions, they are not accessible outside the class. Okay, what are accessible outside the class using object reference are only the public data and the public member functions. Okay, so and this is what is given by the encapsulation property. So in order to discuss in detail this, let me first highlight what this slide tells about. Okay, I have base class, okay, and I have different members, data members and member functions. In the base class, I have divided my members, that means data and functions, with three different scope delimiters, that is private, protected, and public. Okay, so these are the three different scope specifiers that I can provide or I can control my members with. And if I want to inherit a class, from this base class, I have three options. I can use public inheritance, for example, class B publicly inherited from this base class, or class B protectedly inherited from this class, or class B privately inherited from this class. Okay, so for example, if you have publicly derived a child class, so what 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 are this accessibility for the public members? So for public inheritance, all the members that have been declared in the public portion of the base class, they are public in the derived class. That means they can be used inside the derived class and also outside using object reference of this class. Okay, these can be accessed directly by member functions inside the class, and outside that can be accessed using friend functions and non-member functions. Okay, for the public members of the base class, if the child class has been inherited through a protected access specifier, these public members behave just like the protected members of the derived class. They can be accessed directly by member functions and friend functions inside the class. Okay, but they cannot be accessed outside the class. If you want to access it, you have to use functions for that. And if you have inherited the derived class using private inheritance, the public members behave just like private. That means they can be accessed directly by member functions and friend functions, but not outside the class. Same is for protected members of the base class, protected in the derived class and protected in the derived class if the inheritance type is protected, and if the inheritance type is private, the protected members of the base class behave just like private members of the derived class. Okay, for private members, they are hidden in the derived class. They cannot be used directly by any inheritance type. That means by private inheritance, by protected inheritance, by public inheritance. But if you want to access it, they can be accessed by member functions, either public or protected. Public or protected, public or protected. Okay, so that means, for example, we have a private member, for example this int a. Okay, this int a cannot be accessed using this child class or using this child class. Okay, if irrespective whether the inheritance is private or whether this is public or whether this is protected, if you want to access this data member, if you want to access this private data member, you have to use some functions. Okay, and we have used those functions, and those functions are declared, for example, in the public portion. Okay, we'll discuss a detailed program on inheritance. Let me open this one. Okay, let me just uncomment this, sorry, comment this one. Okay, in this class, in this program, I have a parent class A. Okay, and it has a member function in the private, that is show private base, a member function show protected base declared in the protected, and a public function show public. Okay, now I have declared class private A, private A, that has been privately inherited from A, prot A, that has been protectedly inherited from A, and pub A, that has been publicly derived from A. Okay, I want to highlight what can be accessed and what can't be accessed in the derived class with respect to the inheritance type. That means the private, the protected, and the public. Inside the protected, in the private portion, I'm calling this called private, I'm calling this called protected, and this is called public. Okay, called private. Okay, the commented are this one that you cannot access. Okay, means you cannot access this show private base, you cannot access this one. Okay, directly. Only that you can access is the protected and public members. Let me build and run this so that you can understand. No error is good. Okay, let me come to the main. Okay, let me simply, I don't want to run this. First, I want to run the very first private A. Run again. Okay. Okay. In the class private A, there is an object declared object1, and calling object1 is called public. Okay, let's come to this class. Okay, this is called public function of the derived class private A. Okay, see out call public of derived class private A. This has been displayed in show protected base and show public base. Show protected base and show public base. So show protected, this has been printed out, and show this one, show public this one. Okay, if I simply unhide this, okay, and run it again, it will signal me an error. Why? Because this show private The show private has been declared in the private portion of the base class, and this private portion is not accessible in the public portion of the derived class. Okay, so this signals me this is not possible. Okay, let me run again. Fine. Okay, let me just try what else are accessible. If you see here in the private A, I have call private as well as call protected and the third call public. So I cannot use this function and I cannot use this function as well outside this class. Call private, call protected. This will signal me an error. I cannot use the private and protected outside the class. Okay, both I cannot use. If you want to use it, what you have to do, you have to call these functions. You have to call these functions inside this class, inside this function. Okay, for example, call private and call protected. Okay, to call functions declared private and protected scope. Okay, you can use it here, but you cannot use it outside the class directly. Okay, so this is call private of the derived class, and this is call protected of this private class. Okay, you cannot use it directly over here. Okay, this was all about a derived class which have been privately inherited. Let me simply unlock this one. Okay, prod A is a class that has been inherited using protected inheritance A, and it has the same functions. Okay, call private, call protected. You cannot use private of the base over here. You cannot use private of the base inside the protector, but same as you cannot use show private of the base. Okay, but you can use other functions over here. Okay, just like previous one. Okay, so object2 dot call public. Let me come here. Okay, so call public of derived class prod A, call object of derived class prod A, then show protected base. Okay, so show protected call of the base function, show public base. Okay, if you want to call the call private and call protected of this prod A, let me just try, and they will not be accessible. Obj2 dot. Okay, if you see, there is nothing here called private and public. And if you run it, there it will signal you an error. Okay, because they are not accessible. If you want to access it, you have to call these functions inside the only accessible function, that is the public one. Okay, if you want to use it, you can call this function, or this function is here. Okay, protected. Okay, and if you run it, so call private of derived class and call protected of derived class will be displayed. Okay, let us discuss a class that has been publicly derived from the base class. Okay, it has all the same functions: a call private, call protected, call public. Let me just unlock this and lock this one for running. This. Okay. Object 3 call public. Okay, so call public of the derived class public A, show protected and show public base. Okay, if you want to check what are accessible, only the protected base is accessible, the public base is accessible, the show base, show point, and all functions. Okay, so what are accessible outside for this object 3 dot. Okay, so call public and show public base. This was the exception, sorry. Show public base. Okay, you can access the base because the show public base has been declared. This has been declared where in the public portion of the class A. Okay, and this was not possible. obj1 dot. If you see, I cannot access the show public base here. Similarly, I cannot access the show base here. Okay, I can access it only in the public inheritance. Is said here in the public inheritance, I can access only the public members. Okay, I cannot access the protected or private directly. If I want to access, I have to use those functions calls inside the public portion. Okay, I hope this is clear. So this was the program that we just explained, and I just explained to you. Just to give you a revisit. Okay, so this class has 3 portions: private, protected, and public. In private, I have only data member, private member. I'm setting this value and printing this value. In protected, I have protected member. I'm setting this value and I'm just displaying. In public, I have this public member. I'm setting this value and I'm showing it. And I have also set all, that sets the private value and sets the protected value. Show all, they show the private and show the protected value. Okay, I have not used set public because I can set this value outside and I can also print this outside. Here is the main. Okay, and the purpose of this test is that private and protected members of A are not accessible directly through object outside the class. However, they are accessible through public members only through object. Okay, so these are those two functions, set all and show all, that have been declared in public scope of this class. Okay, and this internally calls the private or protected functions that are not accessible outside. Okay, so I have declared object A public member 100. As public member can be accessed outside. Okay, show public. Okay, show public value of A is this. Show obj.set all. Here I am setting the value for the private. This one is 10 and for other one is 11. Okay, and I'm printing it. So show private 10, show protected 11. Okay, so here is the trick. These are the public portions that unlocks what? Execution for the private members, private or protected members. Okay, scope of accessibility: protected members, protected inheritance, intermediate level of protection between public and private. Derived class members can refer to public and protected members of the base class simply by using the member names. That point is that protected data bricks encapsulation. Okay, so encapsulation we have no access or access. When we introduce protected, those data or the protected members are accessible to the child class, but they are not accessible when subchildren of this intermediate child nodes are created. So it breaks one step encapsulation. Scope of accessibility protected members. Object of a derived class can be treated as an object of the base class. Okay. Object of a derived class can be treated as object of the base class. Why? Because the derived class object uh, can have its own functionality, plus it can also use the base class functions. But the reverse is not true. What this means? This means that the parent class object cannot be used for functions to call that is of the child class. Okay, let me give you a simple example. For example, I have this class. Okay, and in this class I have some data members, and I have some member functions. Okay, then I derive another class. Sorry, I derive another class from this parent class where uh, I can have its own data members. Okay, and its own member functions. Its own data members and member function. For example, this is parent and this is, for example, child. Okay, so the slide was saying me that the object of the child class can be used to access the parents, but the reverse is not true. Why? Because, for example, if I have declared an object of this parent is, for example, P, okay, so I can access this data member, this function, and this function through this P, but I cannot access this data member or this data member or this function or this function because they can only be accessed by objects of this class, okay, or objects of the derived class. For example, object of the derived class that has been derived from this child class, okay, from the subchildren of this one. Okay, so P can access what P can access. P can access on the this thing, okay, this one, and this one also, and also this one. Okay, it cannot access this or this or these functions. It is not possible. It is not possible. But the child class, they can access this one and they can also access this one because the child have been declared just like child, um, class child, for example, publicly inherited from parent. Okay. Downcasting a pointer, use an explicit cast to convert a base class pointer to a derived class pointer. If you want to cast, for example, this is a derived class pointer, and you want to convert it to the base class, you can convert it using this way. Okay. For example, in this case, if you want to do it like this, you have to use a parent star and okay, so this is a downcasting. Okay, so this was all about downcasting a pointer. Next is what can be accessed and what cannot be accessed, specifically about the member functions when you do inheritance. In the derived class, or the derived class cannot directly access private members of the base class. Okay, we did this in our programs. The derived class object cannot directly access the private members of the base class. The same is true for the member functions of a derived class. Okay, That is, the member functions of a derived class cannot directly access the private members of the base class. Okay, and this hiding of private members is what gives you the control, okay, or security. For example, parts of the program that you don't want to give access to outside, so you make them as private. If you want to override a base class member function, what I mean by override, for example, there is a function with the same name. If you want to use this function, you can override this. Okay, in order to override a base class member function, pretty simple, and this is possible. In derived class, just apply the new version or the new implementation to the function. Okay, same function name but with different definition. Okay, and the compiler understands it. Okay, when you call the same name using object reference of the derived class, the derived class function will be called. Okay, let me just give you a simple example. For example, this one. For example, here in the parent, I have a class, I have function. For example, I have this function. Let me just make it color this. Okay. For example, I have this function. Okay. And this function has a name. For example, its name is f1. Okay. If you want to redefine it, you can redefine it uh, in the derived class, okay, by again the same name but with different implementation, for example. Okay, so I have the same name f1, for example, the same number of arguments and the same return type but with different implementation. Okay, for example, I have this function and it takes 3 arguments and it sum all of them. This function, it takes 3 arguments, but it does not take the sum. For example, it takes the product of it, but the name is the same. Okay, sorry, it's a mistake. The function name is the same and that is f1. Okay, so this is overriding. Okay, and the compiler understands it because if you call it using uh, this f1 and the number of arguments 1, 2 and 3. Okay, and if you call it by p, for example by p, the compiler will understand that now which function should be called, okay. So if you're calling it by the parent class object, this function will be called. If you're calling it by the child class function, this will be called. Okay, and if you want, for example, if you are in the child class and you want to use this function, for that case you have to use a resolution operator. You have to use a scope resolution operator, and that is, for example, parent scope resolution operator f1 and with arguments. Okay, this is a scope resolution operator that tells that yes, I'm inside this class, the derived class, but I want to access this one. Okay, there are direct and indirect base classes. For example, as we have seen earlier, uh, for example, we have this employee class, that is base class for this hourly class, and we have declared another child minute worker. Okay, so employee is the indirect base class of the minute worker. Okay, that is just like this. Mm, for example, you have this, sorry, for example, you have this as an employee. Okay, and then from the employee you have uh, used another, okay, and then you have called another one, okay. So this is the employee class, this is the employee class, this is for example the hourly work, and this is for example the minute one, okay. So this has been declared from this class, okay, and this is declared from this one, okay. So this is indirectly, this class can also access functionality of this e, okay. So this is indirect base class of this m, okay. Now let's discuss using constructors and destructors in derived classes. Okay, so as we know that constructors are used for initializing members of a class, and destructors are used when an object is destroyed and you want to do the necessary things when an object is being destroyed. That means, for example, you want to save the data in some files and so on, okay. So what is done, for example, you have base class and you have derived classes, and you want to initialize the data members of the base class, and you also want to initialize the members of the derived class. What we have to do in that case, so constructors can be used to initialize the base class, okay, and can be provided in the derived class constructor to call the base class constructor explicitly, okay. Otherwise base class default constructors are called implicitly, okay. Okay, so we may have constructors in the base class and also in the derived class, because the base class constructors and the base class assignment operators are not inherited by the derived class, okay. But there is a way that the derived class constructors and assignment operators can call still them, okay, and we will see an example for that, okay. In the derived class constructor, call the constructor for its base class first to initialize its base class members. For example, we have a no argument constructor in the base class and a no argument or some argument constructor in the derived class, okay. So for that case, when an object of the derived class is declared, the base class, the corresponding base class constructor will be called first, and then the derived class constructor is called, okay. If, for example, we do not have any derived class constructor, then only the base class constructor is called, okay. Just to give you an example, for example, we have a class A which has one argument constructor, and we have a class B that has been derived from class A and it has no constructor in it, okay. So if you want to create an object of the derived class with just one single parameter, so in that case the one argument constructor of the base class will be called, okay. And if, for example, we have a no argument constructor in class A and a no argument constructor in class B, so if an object of the derived class without any argument is created, that means first the no argument constructor of the base will be called, and then the no argument constructor of the derived is called, okay. Is this clear? Okay, so destructors are called in the reverse order. The constructors are called from base, then down to the child and subchildren, okay. And the destructors are called in the reverse order. That means subchildren, then another child, and then the destructor of the parent is called. That means the reverse order. Let me give you an example. Okay, so I have these two classes. For example, this is parent A, and let me just change the color of it. Okay, and this is, for example, B class that has been derived from this class A, okay. And this is derived from this class, okay. And for example, I'm creating an object of this class, for example B and B. Okay, and I'm creating another object B2 with a single argument, for example 4. Okay, so this is an argument constructor. So first this will be called, and this first this the base class constructor is called, and then this one is called. For one argument constructor, the base class one argument constructor is called, and the derived class constructor is called. Okay, for example, this is the destructor. Okay, and this is the destructor, and this is also the, for example, this is also the destructor. Okay, so when this object is destroyed, so the reverse will be called. First this destructor will be called, and then this destructor will be called. Okay, so for initialization, first the corresponding base class constructor is called, then the derived class is called, same as this and this. For the destruction, the process is the reverse, this t and this t. Okay, for example, I have a third class. Okay, for example, I have third class C, and this is derived from this one. Okay, and for example, it is also a destructor. It is also a destructor, and the C class, for example, this C class, uh, it it has some object this, and this is destroyed. So first this destructor will be called, then this destructor will be called, and then this destructor will be called. Okay, if the C class has any constructor in it, for example, it has any one argument constructor in it, so first this constructor will be called, this constructor will be called, and then this constructor will be called. Okay, okay, we will discuss this a very comprehensive program. In this program I took from the Detail and Detail book on inheritance. Here in this class, in this program, I have four different classes. Okay, let me go to the Eclipse window, and then we'll come back here. So inside the Eclipse, I have five different classes. Okay, this is our header file for the point class. Okay, here I am declaring a class with name point, and this has two data members x and y declared in the protected scope, and it has two argument constructor that is setting the value for x and y at 0. Okay, initializing it, and it also has a destructor in it. Okay, let's come to the point class. Okay, this is the point class. Here we need to include the header file. In this point class, the two values, the two argument constructor a and b, these values are set as corresponding x and y, and then these values are displayed with the cout. Okay, point constructor this. Okay, for the destructor, the implementation is just a single statement, output statement, a destructor, and with points. Okay, then we have a header file for circle, and the circle includes the point header file. Okay, and the circle inherits the point class with public inheritance. It has a constructor in it that takes three arguments for the radius, for the x and y. Okay, and it also has a destructor in it, and it has a radius data member declared in the private scope. Okay, let's see its implementation. For the circle, the three argument constructors are initialized, okay, and this directly calls the constructor, the corresponding two argument constructor of the base class, okay, and after it, the radius r is set to this value, okay, and a single statement, okay, cout statement. For the destructor, a single statement is called, okay. So let's check again. Point header file, it declares a point class with two argument constructor in it. Without any argument constructor, that is the default constructor. X and Y. Okay, and it has this thing, a two argument constructor with value set and a destructor. Let's check the test. Okay, for the test, we have declared a point object, okay, a point object with two arguments 10 and 14. If you see here, first this will be this will be called 10 and 14. So the 10 will be assigned here to x and 14 will here, then point constructor this will be displayed. Okay, let me build and run it. If we build it, project, and run it, and we come to the test. Okay, so if you see here, point constructor with 10th 14, that is this message, point constructor with this value, okay, and then the point destructor. How the destructor is called? When you reach just the end of the body, this is a local body because I want to check both the constructor and destructor. So outside this body, the P will no longer be visible. That means the P is destroyed somewhere here, okay, after this block, before this end statement, okay. Then there is this new line cout, and then for circle, okay. So circle, I am sending these three arguments. If you check the circle, so first the point class constructor will be called, okay, then the circle constructor is called, this message is displayed, okay, and if you come again, then this new line, again the circle, okay, and then somewhere here when the before the return statement, the the two objects circle 1 and circle 2 are destroyed over here. So circle destructor, pointer destructor, okay, and then the circle destructor. All right, okay. So inside the constructor, the order is from parent to children. For the destructor, the order is first from the child and then from the parent and so on. Okay. Yes. First destructor of the child node, destructor of the corresponding destructor of the parent, destructor of the child, corresponding destructor of the parent. Okay. So this is the class, this is the point header, okay, declaring the point class, then implementation for the point, declaration for the circle, implementation for the circle.cpp, and then this is our test, this is the output, okay. We can if we assign base the derived class object to the base class, okay, so the derived class object has more members in the base class object, this is for sure. So extra data is not given to the base class, the extra data is not given to the base class, okay. And the derived class object, base class object, okay, if we assign the base class object to the derived class, in some cases it may not work properly, okay. uh, we can mix the base and derived class pointers, okay, by 4 ways. Referring to a base class object with a base class pointer, this is allowed. Okay, for example, you have a same object for the base class, you assign a pointer to it. Same is for the derived class object with a derived class pointer. This is also allowed, okay, because here the object type is the same. Both are same classes. Both are same classes, okay. Referring to a derived class object with a base class pointer, okay, it may possibly give you a syntax error. Okay, referring to a base class object with a derived class pointer, this will give you a syntax error, okay, because this is more functionalities than the first one. So only allowed is when you are doing for example, you have let me write here. For example, you have two objects, for example a, and you have pointer a, okay. So this a and this a can work with a, okay. If you have b, okay, and you have a pointer b, okay, so that means that this can let me use this is single pointer, so bb can work with a single b, okay. But a and b, for example, if you are assigning with a reference of b, it may not work. Reference of b, it may not work, and same as this bb, if you are assigning reference of the a object, this may not work, okay. This may not work, or this may give you a syntax error. Because if you see here, in this case, if you see here, it's fine because the class types in both cases are the same. Both are a, and also here the class type in both cases are the same, okay, b class and a class. Okay, composition versus inheritance. Inheritance is a relationship. For example, circle is a shape, okay, and rectangle is a shape, okay. For example, a faculty is an employee, okay, or admin is an employee, okay. So this inheritance provides is a relationship. Has a relationship means when you want to use object of one class inside another class without any inheritance, okay. For example, composition class is an object from another class. A is a data member, is a data member. For example, employee is a bird or employee has a bird, okay. Employee is a bird, this is wrong. Employee has a birth date. In this case, employee is a separate class. Birth date is a separate class with members is day, month, and year. For example, I have an employee class, okay, and I have another class is birth date, okay, an employee class, and I have a birth class, okay, employee, okay, make it right, and then I have birth date, okay. So this is data members or functions for day, for example for month. For example, enter the month, enter the day, enter the year, etc. Okay, so for example, it has a function. It has a function in it, and that is enter birth date. Okay, enter birthday. Okay, so inside this it can use an object. Okay, for example, its object is objb. Okay, so inside the employee can use, for example, in public portion, an object of class date, some object, for example, some object b. Okay, it can use. So this is what is this? This is has a relationship. This is has a relationship. This is has a relationship, and it is completely different from the inheritance. It means one object can interact inside another class. Okay. Then we have uses a relation. One object issues a function call to a member function of another object. Yes. And knows a relationship. One object is aware of another object as what it is doing and what data it has. Okay. Contains a pointer handler or reference handler to another object. Okay. Also called an association. Okay. Uses a relationship. One object issues a function call to a member function of another object. Okay, we can have it. For example, inside the object, we can call functions of another object. So this is uses a relation. Knows a relation, one object is aware of another. For example, we use a pointer handler or a reference handler to another object. Okay, so you can call functionalities of that object by this reference. This is called association. Okay, this was all for today for the inheritance. Just to recap what we have studied in this class, we studied inheritance. Okay, genetic inheritance we normally see in our daily lives when children has properties resemblance to their parents. Okay, we also discussed generics versus specifics. Parent class have generic properties, child class have generic also with some specified attributes or properties in it. Okay, we discussed vehicle, in which case we have inherited truck and car classes. Okay, we also discussed inheritance, single inheritance, where one class inherit from one base class, and multiple inheritance, and one class is inherited from multiple base classes. We also discussed the scope accessibility for public, private, and protected inheritance types. Okay, we also discuss inheritance hierarchy. Okay, where we have indirect base classes. Okay, and we discuss some basic examples. Okay, and some basics about the constructors and destructors. When for the inherited classes, the destructors are called first and bottom up approach. Okay, the constructors are called in a top down fashion: parent, intermediate parents, and then children. Okay, we also discuss this point circle class. Okay, with header files. Okay, and the header files are normally included in the same folder with .h. Okay, it provides the declaration. Header file provides the declaration, and the implementation is provided by the corresponding CPP source files. Okay, this is the class scope. I want to use a point constructor of the point class. I want to use the destructor that is in the point class, and this point class was declared in the point header file. Okay, this was declared in the point header file. Okay, so this was all for today. See you for the next class on important friend virtual functions, abstract virtual functions, abstract classes, and polymorphism. Okay, see you in the next class. Bye.